As we begin calculating more difficult parenteral nutrition administration scenarios, it is important to ensure that the caloric values of the nutrients being administered are understood. This video will cover those values and some of the reasons why there are slight differences as compared to nutrients consumed orally. The three nutrients that supply calories to the body via parenteral nutrition are protein, lipids, and carbohydrates. Vitamins and minerals help the body metabolize these nutrients but do not supply any caloric value. Starting with protein, administration is via amino acid solutions and come in standard as well as age and disease-specific formulations. The base solutions typically range from 3% to 20% concentrations, containing both essential and non-essential amino acids in a balanced mix. The percentage value indicates how many grams of protein per 100 ml of solution. So a 15% amino acid solution would provide 15 grams of amino acids per 100 ml. Since parenteral nutrition is usually administered in volumes such as liters, you would need to multiply these values typically by 10 if you are talking about a liter to get the number of grams within that liter. So 15 grams times 10 equals 150. So a 15% 1 liter parenteral nutrition solution of amino acids would contain 150 grams of protein. Each gram of protein contributes 4 kcals per gram, so caloric calculations are the same as you would complete if food was being administered orally. To finish this example, 150 grams of protein times 4 kcals per gram equals 600 calories from protein. If parenteral nutrition is expected to last for an extended period of time, the amino acid mix should contain glutamine, which assists in protecting the gut epithelia tissue lining, and choline, which helps protect the liver from hepatic fat deposits. The next nutrient is carbohydrate. Carbohydrate is the primary energy source used in parenteral nutrition, with dextrose monohydrate being used almost exclusively. A very important note here, dextrose monohydrate yields only 3.4 kcals per gram. At times, glycerol can be used as an alternative energy source, which has shown to be protein sparing when administered concurrently, as well as providing 4.3 kcals per gram. But dextrose monohydrate is almost always the carbohydrate of choice. Concentrations range from 3% to 70%, and just like protein, the percentage represents how many grams of the nutrient will be found within 100 ml of solution. Lastly, we have lipids. Fat is administered in the form of stabilized emulsions of long-chain fatty acids, with at least 2 to 4% required to be essential. The primary sources of lipid emulsions are soybean oil or the combination of soybean and safflower oil. The letters IVFE stands for intravenous fatty acid emulsion, and these come in 10%, 20%, and 30% solutions when hung separately in 250 and 500 ml containers, but can be mixed at different percentages when combined within a 3-in-1 solution. 10% emulsions provide 1.1 kcals per cc or ml, so to calculate the calories, multiply 1.1 times the volume used. 20 and 30% emulsions supply 2 and 3 kcals per cc or ml respectively. Next, we will briefly discuss some of the things to consider when a patient requires parenteral nutrition, while also continuing to challenge you on TPN calculations. RDStudy.com video tutorials are produced and owned by Nutrition News Network LLC. Any copying, reuse, or redistribution, in full or in part for any purpose without the written consent of Nutrition News Network LLC is prohibited. All rights reserved.